Hello.
Hello, are you getting my voice here? So please reply in the chat box. I enabled the chat window here. Yes. I got the reply from your side. I'm going to close the chat window here. So thank you for giving the reply for not getting the voice. Okay, just I have given the review. So what we have covered in the previous lecture. Okay. So I have given the difference between the substitution ciphers and again the transposition cipher here. So what I have given the substitution cipher means, so in case of the substitution cipher, So the plain text characters we are going to replace with the cipher text characters. Okay, that is called as the substitution cipher. And in that substitution cipher, we have studied the different algorithms. For example, there are total 5 algorithms are there. So Caesar cipher, one-time pad, and again the monoalphabetic cipher, polyalphabetic cipher, and again the playfair cipher. So in the previous lecture also we have covered the transposition cipher. So why these ciphers are called as the transposition cipher here? Because in case of the transposition cipher, whatever the plain text characters are there, the plain text characters just we are going to do the rearrangement of the plain text characters here. See, in this case, transposition cipher, we are not going to replace the any characters here. Okay, whatever the characters are there in the plain text, on that plain text characters, we are going to do the rearrangement of plain text. Okay. So this is the difference between substitution cipher and again the transposition cipher here. Okay. And now already the two types of the transposition cipher we have covered. Okay. So one is the Ralph's technique, and again second one is the columnar transposition technique. Okay. So the transposition cipher now consider classical transposition or permutation ciphers. Okay, the permutation means it is the permutation and again the combination. So how many ways you can rearrange the plain text characters? Okay, that is called as the permutations. And these hide the message by rearranging the letter order. And without altering the actual letters, used can recognize these since have the same frequency distribution as the original text here. Okay. And this is the Ralph's cipher. So in this Ralph's cipher, so what we did here, so this is a very easy algorithm. Okay. So write the message letters out diagonally over a number of rows here. And then read off cipher row by row. Okay, whatever the example I have given. Okay. That example is meet me after the toga party. And how we have written this message here. So in the diagonally row by row, we have written this MEET, MEAFTER, THE, TOGA, PARTY. Okay. And cipher text we have obtained here by reading this diagonal in the form of the row wise here. So the first row is that MEMATRHTGPRY. And again the second row is ETEFETEOAAT. I mean, this is the encryption we have done here at the sender side, and we have got the cipher text here. Now, what about the decryption process? So the decryption process is that whatever the cipher text we are going to obtain here, and along with this cipher text, we have the Ralph's depth here. So the Ralph's depth is the 2 here. And again, here the same case, again, we are going to write in this way. And from this, we are going to obtain the plain text here. Okay. So in that way, we can do the encryption and again the decryption using the rail fence cipher here. Okay. So now the row transposition cipher. So this the row transposition cipher, it is also called as the columnar transposition cipher also. Okay. You can hear the give the name as the row transposition or the columnar transposition ciphers here. That is a more complex scheme. Okay, you can why it is called as the more complex scheme. See here the multiple rounds you can increase here. See the only once you are got the cipher text here. Again, this cipher text you can write using by using this key here. Again, you can go for the third round. Again, you can go for the fourth round, fifth round, again, sixth. Number of ways you can write this row transposition cipher here. That's why it is called as the more complex scheme here. Okay. And whatever the rounds, how many rounds we are going further here, that rounds must be conveyed to the receiver side. So the receiver is going to obtain the proper plain text here. Suppose the sender is going to execute the two rounds and the receiver is going to execute the only one round. Then it is very difficult to get the original plain text here. Okay. So that is why write letters of message out in the rows over a specified number of columns. Then reorder the columns according to some key before reading of the rows here. And the key is 4, 3, 1, 2, 5, 6, 7. So the any sequence you can take there, but don't take the very simple like the 1, 2, 3 sequentially. Okay, 1, 2, 3, 4, 5, 6, 7. Make it complex. So always we need to think about how we are going to create the or how we are going to increase the complexity of this algorithm. Okay, that is important. Then only we will get the more security. Otherwise, we will not get the more security. So the plain text we can write the row by row here. So the attack postponed until 2 a.m. and X, Y, Z, these are the filler letters are there. Okay. And how we are going to obtain the cipher text here? So the cipher text we need to read the column wise here. Okay, this is the first column, second column, third column, fourth column, and again the fifth column, sixth column, and again the seventh column here. So the first column has the TTNA, second column is about APTM, third is TSEO, fourth one is AODW, fifth one is the COIX, sixth one is the KNLY, and the last one is the PETZ. Okay, so in that way we can achieve the row transposition ciphers here. Okay. Now the last point is about the rotor machines. So now see the for encryption and again for the decryption we have studied the two techniques. One is the substitution technique and again the next one is the transposition technique. Now the third technique is called as the rotor machines here. See the rotor machine, it is not kind of any algorithm. So you can say rather than you can say that this is the one machine. Okay, you know about the electrical machine here, electrical motor is there. So 1 HP motor, 2 HP motor, 3 HP like that. We are using for is the agriculture purpose. That rotor, motor is called as the rotor motor is there. So inside one rotor is there, and where we are going to supply the electricity at that time, that rotor is going to take the rounds. Okay. So the logic used in that rotor machine, okay, that we are going to see here. So how that logic is implemented and how that logic we are going to use in our cryptography. Means for making the encryption and again for the decryption, how we are going to use the logic of rotor machines. Okay. So again, this whatever this logic is considered in the rotor machines, this is also very, very easy. Okay. There is nothing any difficulty or the any complexity it is there. Okay. So in case of the rotor machines, so the multiple stage substitution algorithms. Okay. So why it is called as the multiple stage substitution algorithms? Okay, I will explain you that. And before modern ciphers, rotor machines were most common product cipher. Okay, and it was widely used in World War II. Okay, the concept of rotor machines was used in the World War II here by German Enzima, Allied Anglian, Japanese Purple. Okay, and it is implemented a very complex varying substitution cipher. And it is used a series of cylinders, each giving one substitution which rotated and changed after each letter was encrypted. So how that cylinders are using here and how the cylinders they are going to rotate here, okay, that we will see the with the help of the example. Okay, so the rotor machines are these are the multiple stage substitution cipher algorithm. So why it is called as the substitution algorithm? Because here we are going to replace the plain text character with the cipher text characters there. Okay, that's why it is related to the substitution algorithm. And before modern ciphers, so the rotor machines were most common product cipher, and it was totally used in the World War II. Okay, and it is implemented a very complex varying substitution cipher, and it is used a series of cylinders. Okay, the we are having the different cylinders, fast cylinder, again the slow cylinder, and again the medium cylinder. Okay, so how it is implemented the rotor machines? Okay, you can see here. So the before modern ciphers, the rotor machines were most common complex ciphers in use. Okay, means whatever the transposition cipher and again the substitution ciphers are there. Before that also these rotor machine concept have been used. Okay, and it was widely used in World War II here. Okay. And it is used a series of cylinders, each giving one substitution, and which rotated and changed after each letter was encrypted. With the three cylinders have the 263 is equal to 17,576 alphabets. Okay, then you can imagine that the three cylinders they are going to have the 260 17,576 alphabets here. Okay. So this is one Haglin rotor machine. So this is one example of the rotor machines here. Just you can observe this one. This machine is used for encryption and again for the decryption process here. Okay. Now this is the inside logic of the rotor machine. So which principle is used in the rotor machine? So this is the principle. So here you can see that we have the different two diagrams here. So one is the called as the A, that is initial setting, and second we have the setting after one stroke. Okay, and these a vertical whatever the you are observing here. So these are the called as the cylinder. Okay, so this is the fast rotor, this is the medium rotor, and again this is the slow rotor. Again, in case we have the fast rotor, again the medium rotor, again the slow rotor here. Okay. So in case of the fast, see the every cylinder is having the 26 pins are there. Okay. So the every cylinder they are having the 26 pins. Now here you can start. This is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 20, 21, 22, 23, 24, 25, 26. Why? Because the 26 alphabets we are having. Because here we are going to consider the encryption of these alphabets. Okay. So that is why the each end for the left and again for the right side for the every cylinder we are having the 26 pins are there, and each pin is assigned one integer, and to that integer we are going to consider the plain text character here. Okay. So and whatever these numbers we are not going to find here sequentially order here. So why we are not going to write these here in the sequential order? Okay, because we are going to increase the complexity of this rotor machine principle. Okay. So for increasing the complexity, if I am going to write the sequentially from the 1, 2, 3, 4 like that, see there will not get the any more and more security here. Okay. So again, whatever the safer text we will get, so the any hacker or the any third person easily they can understand this principle, and again they are going to hack the easily here. So that's why our aim is that we need to provide the more and more security. So that's why we need to increase the complexity level of this any algorithm here. So that's why these numbers were not written in the sequentially manner. Okay, now everywhere you can observe this one. This is the 21, 3, 15, 1, 19, 10, 14, 26, 28, 16. So there is no any sequence. Here also 26 is the first time, and again after that we have written 1, 2, 3 up to the 25. So here we don't have the any sequence. Here we have the sequence 1 to 26. Again output of this there is not we have considered the any sequence here. So now here, so how the encryption is going to happen here? I request you all please give your 100% attention here. Once you are going to understand this principle, then it is very easy, okay, to understand the rotor machine principle here. Okay. Now you can consider the first rotor here. So in case of the first rotor, so we have the 26 pins here. 26 alphabets are there from A to Z. Now suppose I have to encrypt the ABC here. Okay. I want to encrypt the characters A, B, and C here. So what is the pin assigned pin for the A here? 24. What is the assigned pin for B here? 25. What is the assigned pin for C is here? 26 here. So here, where is the 24 is matching here? So the 24 is going to match to the 24 here. Again, the 25 is going to match to the 25 pin here. Again, the 26 is going to match to the 26 here. Okay, this is about the fast rotor. Now you can relate to the fast rotor to the medium rotor here. Now the 26 number is assigned to the 7 number here. 25 number is assigned to the 22 pin here. And again the 24 pin is assigned to the 24 here. Means the 26 to 7 here. Again from the 7 to 7 it is going to match here. Again the 22 is going to match to the 22. Again the 24 is going to match to the 24 here. Okay. Now the 22 pin is assigned to the 13 pin here. 24 is assigned to the 18 here. 7 is assigned to the 20 here. So the 13 is going to produce the 13. 20 is going to produce the 20. And again the 18 is going to produce the 18 here. Now what is the character for 18 here? B. What is the character for 20 here? E. What is the 13 for? I. So that, so the plain text character A is to the B, cipher text. The plain text character B, we got the E as a cipher text, and the plain text character C, we got the I is a cipher text here. So this is the logic behind the rotor machine principles here. Okay, this logic is the very easy here. Now this is the initial setting is there. Now setting after one stroke means after okay, after supplying the electricity, it is going to take the number of rounds here. So after that rounds, so just we are going to check that. Now the A is assigned to the 23, B is assigned to the 24 pin, and the C is assigned to the 25 here. So the 23 is going to match to the 23, 24 is going to match to the 24, okay, and 25 is going to match to the 25. Now the 23 is assigned to the 20, 25 is assigned to the 23, 24 is assigned to the 25 here. So the 20 is assigned to the 20, 23 is assigned to the 23, 25 is assigned to the 25 here. Again, the 20 is assigned to the 1, 23 is assigned to the 9, 25 is assigned to the 17 here. So that 1 is assigned to the 1, again the 9 is assigned to the 9, 17 is assigned to the 17 here. Now you can observe that for 17 pin number, we have the ciphertext character is D. For 9 pin number, we have the O here. Again, for the 1, we have the Y here. So that accordingly, for the plain text character, we got the D as a ciphertext. For the plain text character B, we got the O as a ciphertext. For the plain text character C, we got the Y as a ciphertext here. Means in that way, we can have the encryption technique and again the decryption technique. So how we are going to do the decryption? So the exact reverse of this one. You can go to the D to the 17. Again, we will get the same plain text here. That is the B. Okay. Means this is called as the encryption and again the decryption process by using the rotor machine principles here. Okay. So this is the very easy algorithm is there. Just I will give the 2-3 minutes time. Just you take down the diagram here. Because the diagram is very important. Based on this diagram, only we are able to explain the algorithm here. Okay. Okay, this is a diagram for the rotor machine principle. So, this is the end of the syllabus of the first chapter. Okay, so we have covered the classical Cipher techniques and terminology, monoalphabetic substitution ciphers, script analysis using letter frequencies, Playfair cipher, polyalphabetic cipher, and again the transposition cipher, and again the rotor machine. Okay, all these algorithms we have covered from the first chapter here. And this is the last point is about the content beyond the syllabus. Okay, so the content beyond the syllabus is that we have one standard algorithm. So this algorithm is called as the triple DES. Okay, so in short, I will explain this algorithm. So the DES is called as the data encryption standard. Okay, that is called as the triple DES. So remember this one. There are different types of the DES algorithms are there. Now the name of the second chapter is the only data encryption standard. Okay, so we have the till now we have studied the only single character encryption, but henceforth we are going to study the multiple character encryption here. Okay, we have the 64-bit plain text. Again, we have the DES cipher, DES reverse cipher, DES cipher, and again we are getting the C as the cipher text, that is a 64-bit cipher text. And here why it is called as the triple DES, because here you can observe this in this diagram in the middle one. So what is in that? So here we have the different three keys are there. The key K1, K2, and again the K3. So in this algorithm, we are using the three keys. So that's why it is called as the triple DES. Okay. The same key for the DES cipher and again the DES reverse cipher. The same key K2 for the DES reverse cipher as well as for the DES cipher. And the same key K3 we are going to use for the DES cipher and again the DES reverse cipher. Always remember this one in this our subject. The left hand side it is going to represent the encryption process, and the right hand it is going to represent the reverse process, that is called as the decryption process here. Okay. So in case of this encryption, so we are going to provide the plain text as the input and we are getting the cipher text as the output here. And here in the decryption process, we are providing the input as a cipher text and we are getting the plain text as the output here. Okay, this is the triple DES algorithm is there. Okay, so we'll see that what is the triple DES key algorithm. Again, detail into the second chapter here. Just you take this the content beyond the syllabus. Okay, so in this way we have completed the first chapter here. So just you can observe. So what is the syllabus of this one? So the each and every point I think we have covered from this chapter. Okay. So here you can see the symmetric ciphers. So in case of the symmetric ciphers, we have studied the overview and services, mechanism and attacks, OSI security architecture, a model for network security, classical encryption techniques, symmetric cipher model, substitution techniques, transposition techniques, and again the rotor machines. All the points we have covered from the first chapter here. Also, we have studied the content beyond the syllabus. Okay. Now, we will start our second chapter here. So the second chapter we will see. So what is the second chapter? Okay, name of the second chapter is that the block cipher and again the data encryption standard here. Okay. So what is the block cipher and again the data encryption standard? This is the syllabus of the chapter. So in that syllabus of the chapter, we are going to see the different points. Simplified data encryption standard, block cipher principles, the data encryption standard, the strength of DES, differential and linear cryptanalysis, block cipher design principles, and block cipher mode of operation. These are the syllabus points for the second chapter. And these are the assignment questions. So the assignment questions are there. Explain CFB. CFB means counter feedback operation with a diagram. Second question, illustrate the working of single round of data encryption standard with diagram. Third one is about explain with a diagram the overall scheme of data encryption standard encryption. Fourth one is explain with the diagrams electronic code book and again the Cipher block chaining operational modes of block Cipher. Fifth one is the what is the purpose of yes boxes in DES algorithm. Sixth one is describe the Cipher block chaining mode of block Cipher. Seventh, list the various types of cryptanalysis attacks and define each. And eighth one, explain all block Cipher modes of operation with suitable diagram. And the ninth one, explain single round of DES. The last one is the 10th one, discuss the strength of DES algorithm. Okay. So these are the 10 assignment questions I have given here. So what is the title of the chapter here? As per the requirement of triple PE. So the block is nothing but the piece of code. Okay, here in case of this our subject, we are going to consider the block is nothing but the piece of information. Okay, that is called as the block here. And Cipher in cryptography, Cipher or Cipher is an algorithm for performing encryption or decryption. So whatever the algorithms we have studied that, these are the Cipher algorithms. Okay, for the encryption purpose and again for the decryption purpose. Okay. And the data is called as you know about the data. So the data are characteristics or information visually numeric that are collected through observation. Okay, that is called as the data here. And the encryption is that. So we know about the now what is the encryption? It is the converting plain text into the ciphertext characters. Okay, the coding or conversion you can consider. And it's the standard. Standard is nothing but a level of quality. Okay, this is the meaning of block cipher and data encryption standard here. So the block is nothing but it is a piece of information. Cipher in cryptography, a cipher or cipher is an algorithm for performing encryption or decryption. And the data are characteristics or information, usually numeric, that are collected through observation. And encryption is about coding. Coding means conversion. Okay, the conversion of plain text into the ciphertext. And the standard is the level of quality here. So about central idea of the chapter. So in this chapter, we are going to first of all learn what are the block cipher. What are the block cipher principal modes of operations are there. And the next one is the data encryption standard. So the data encryption standard algorithm is the very, very important algorithm, okay, in our cryptography subject. Okay. So all the things in detail we are going to learn in this chapter here. And the importance of the chapter in subject syllabus is that, so the data encryption standard is symmetric key algorithm for the encryption of digital data here. So whatever the data encryption standard algorithm is there, is the very, very important. Okay. So that's why this chapter is having the importance in this subject. And the last point is about the chapter objectives and outcomes here. So the objectives are students will learn different types of the block cipher principles. The students will learn working of data encryption of standard. The students will learn the types of block cipher modes of operations. And the outcomes are that, so the students will be able to differentiate block cipher principles. Students will be able to analyze the DES algorithm, and the students will be able to analyze the block cipher modes of operations here. Okay, this is the all the points regarding the chapter number 2 here. Okay. So here in this case, the actual point we will study in the next lecture. Now the point is the time is not there. Okay, so we can stop here. So I'm going to enable the chat window here. So if you are having any doubt or any problem, you can raise here. Otherwise, you can put your attendance. Okay, in the chat window.